Hello my dear students, welcome back to CSIR 2021 June free crash course series. If you haven't subscribed yet, please subscribe. Today we can study about Km. Km is the Michaelis-Menten constant and which is equal to the concentration of substrate at which half the active site of enzyme are filled. And this Km provides a measure of substrate concentration which is required for significant catalysis to take place. And this Km value for an enzyme depends on the particular substrate which is involved in the reaction, and Km is also depend on various environmental conditions such as pH, temperature and ionic strength. This is the equation for Km. Km is equal to rate constant. K is rate constant. K minus 1 plus K2 divided by K1. This equation we have studied in the previous section. E plus S is converted into enzyme substrate complex. Then it converted into enzyme plus product. And these are the rate constant. K1, K2, K minus 1 and K minus 2. Km reflect the strength of enzyme substrate interaction. We know that Km is equal to K minus 1 plus K2 divided by K1. These are the rate constant K1, K2, K minus 1 and K minus 2. Consider a case in which K minus 1 is greater than K2. What is K minus 1? It is the rate constant where enzyme substrate complex convert back into substrate plus enzyme. And K2, what is K2? Where enzyme substrate complex convert into product plus enzyme. So what happens if K minus 1 is greater than K2? This step is greater than this one, this rate constant K2. What happens if K minus 1 is greater than K2? Enzyme substrate complex, this one dissociate into enzyme plus substrate more rapidly than product is formed. Okay. So the equation will be K minus 1 divided by K1. We can omit this one K2 because K2 is very less compared to K minus 1. This is the dissociation constant. K minus 1 divided by K1. So here Km is equal to the dissociation constant of EX complex when if K2 is smaller than K minus 1. So Km is the measure of strength of enzyme substrate complex. And a high Km indicate weak binding, or we can say large Km has low affinity for substrate. A low Km indicates strong binding. Otherwise, small Km has high affinity for substrate. Okay, we can apply numbers here. Okay, Km is equal to 1 by 2. Which is higher? 2 is higher. K minus 1 is less. Answer is 0.5. So Km is 0.5. If we can apply here 4 by 2, what is the answer? 2. So that case Km is higher. A low Km has more affinity for substrate. Low Km means enzyme has more affinity for substrate. High Km means this enzyme dissociate back into enzyme plus substrate. Okay. Now we can study physiological consequence of Km. Example, alcohol consumption. You know that some people, if they consume alcohol, what happens? They are very sensitive to ethanol. They exhibit facial flushing and rapid heart rate. Even if they are consuming small amount of alcohol, then also they develop these symptoms. How? We can study. Ethanol is converted into acetaldehyde, where liver. In the liver, ethanol is converted into acetaldehyde with the help of which enzyme? Alcohol dehydrogenase. And if this acetaldehyde is in excess, it causes these symptoms. Symptoms like facial flushing and rapid heart rate. But normally what happens is this acetaldehyde is converted into acetate. with the help of which enzyme? Acetaldehyde dehydrogenase. And this acetaldehyde dehydrogenase is of two forms, two types. A low Km acetaldehyde dehydrogenase and high Km acetaldehyde dehydrogenase. Low Km acetaldehyde dehydrogenase means it has high affinity for substrate. And low Km acetaldehyde dehydrogenase is a mitochondrial form. High Km acetaldehyde dehydrogenase, that means it has low affinity for substrate. And high Km acetaldehyde dehydrogenase is a cytosolic one. In susceptible person, this mitochondrial form, which has low Km, is less active. They have only high Km enzyme, that is high Km acetaldehyde dehydrogenase, which is cytosolic, which has low affinity for substrate. Which is the substrate here? Yeah, acetaldehyde. So this high Km enzyme has low affinity for the substrate. That's why less acetaldehyde is converted into acetate, and resulting excess amount of acetaldehyde in blood. And this causes physiological effects. You have to study these things: high Km, low affinity, low Km, high affinity. These type of questions are sure for CSIR point of view. For example, in cancer treatment, they may provide two type of enzymes. One has low Km, one has high Km, and you have to find the Km value from the graph. Okay, observe the graph and find out which one has low Km or high Km. Okay, so if you like this video, please subscribe and share. Thank you.